Hi everyone and welcome back to Maths and Physics and Assignments. Today's lesson on momentum, physics. We're looking at Gauteng 2015, the September paper or prelim paper, looking at third variation of 7. So this is where two objects are moving together and one separates from the other one. Okay? So an ice skater with a mass of 54 kgs is holding a box as part of an act. She skates with a velocity of 0.08 meters per second east, so that's the initial velocity. She throws the 1.5 kg box directly away from her with a velocity of 10.2 meters per second. 5.1 state the principle of conservation of linear momentum for 2 marks. 5.2 calculate the ice skater's velocity immediately after throwing the box away from her for 4 marks. 5.3 calculate the magnitude of a force exerted on a box by the ice skater if she exerted this force for 1.2 seconds. So once we bring in force and time, we're working with impulse, right? So principle of conservation of momentum. 5.1 state the principle of conservation of linear momentum. So the total linear momentum of a closed system or isolated system remains constant. 1 mark for closed statement, closed system, 1 mark for remains constant or is conserved. Right now, 5.2, they say calculate the ice skater's velocity immediately after throwing the box away. So what is the ice skater's final velocity after he got rid of the box? So initial velocity, we have the 54 kg and the 1.5 kg moving together at 0.08 meters per second, and we have the final velocity of the 1.5 kg box at 10.2 meters per second. Right, so to calculate, we first need to specify that we're taking east as positive, or to the right as positive. Right, so my sum of my initial momentum must equal the sum of my final momentum, right? They asked me there. So I'm using conservation of linear momentum, right? Mass 1 plus mass 2, because he was holding the 1.5 kg box, they become 1. And they were moving at one velocity of 0.08. Mass 1, V1 final plus M2, V2 final. So mass 1 was 54. We don't know what the final velocity is there. Mass 2, 1.5 kg, and that final velocity there was 10.2. Right, so we multiply out. There I took 54 V1F to the other side. 54 plus 1.5 times 0.5. If I bring it to this side, becomes negative. 54 plus 1.5 times 0.08. There 1.5 times 10.2. So 1 mark there for correct substitution, another for correct substitution. Correct formula, 1 mark. All right. From there, the answer I get there, divided by the negative 54, gives me negative 0.2 meters per second. If I drop the negative, that technically means it's moving opposite. If positive is east, then negative is west. So this should read 0.2 meters per second west. Sorry there now, I forgot to take out the negative. Now, when you are typing and you're tired and you just copy. It's not an excuse, but yeah, that's what I've done. Right, next question. Calculate the magnitude of the force exerted on the box by the ice skater if she exerted the force for 1.2 seconds. So remember the box weighed 1.5 kg, right? It had an initial velocity of 0.08 meters per second and a final velocity of 10.2 seconds, right? So they want force and they've given us time, so I'm using force times the change in time equal my change in momentum, which is my mass times my change in velocity, or written differently, mass times final velocity minus initial velocity, right? So my time there is 1.2 seconds, the mass of the box 1.5, final velocity was 10.2, initial velocity 0.08. Right, if I subtract that 2 times 1.5 divided by 1.2, it gives me 12.5 newtons east, meaning the answer is positive, therefore the direction is east. 1 mark for correct formula, 1 mark for correct substitution, 1 mark for final answer. All right. So I hope you understand, hope you enjoy the lesson. God bless. Bye.